Welcome back to the course on electronics made easy. In the previous lectures, we have seen what is an Arduino. We have seen the programming of Arduino, and even some of the interfacing also we have done. Now today we will go for the very interesting interfacing project, and you will be very happy when you will finish this kind of interfacing. Now today we are going to interface the ultrasonic sensor with the Arduino, and again we'll go ahead and while interfacing the Arduino with ultrasonic sensor, we will try to build a simple project of a doorbell. Means specifically the ultrasonic sensors are used for the distance measurement purpose. Ultrasonic wave when strike on the particular object and come back, the time we have to calculate, and depending upon that time we can calculate the distance traveled by ultrasonic waves. Okay, and that distance we can calculate with the help of Arduino programming. If the distance is below some specified value, then we may turn on the buzzer. Okay, this project we are going to do right now. All of you are ready? Yes, I think all of you are ready. For that purpose, what equipments we need? We need the ultrasonic sensor. Now this is our ultrasonic sensor. This ultrasonic sensor readily available in the market. The name of this ultrasonic sensor is the HCSR04. And here you can see that two ultrasonic sensors are there. One of them we are using as a transmitter. Here you can see that T is written and another is the receiver. And here signal conditioning circuits are already there. If you have purchased the ultrasonic sensor separately, then you have to build the sensor signal conditioning circuit yourself. But now here inbuilt package is available and that is easy to use. Here this sensor comes with the 4 pin. First pin is the VCC, second pin is the trigger, third pin is the echo, and last pin is the ground. These are the 4 pins. To make the connection, what I did with the help of soldering gun, I have connected these connectors. Okay, colors actually we have to use as per our identification purpose, but here I have used the wire color randomly as they are available. Okay, now the soldering is already done, but my suggestion is that you do the soldering whenever you need. Okay, for that you also need the soldering gun. Now as we have seen, this is the Arduino board. Okay, having the total 14 digital pins, ground pins are also there, analog pins are also there, then 5-volt supply ground pins are also available for the interfacing purpose. Okay, this we need. This is the simple low cost buzzer for giving the sound indication. Whenever the distance is below some specified value, the buzzer should be on. That is our project intention. And one more thing you need, that is the cable. You need the Arduino to laptop or computer cable. This is the USB cable available. Okay, only these materials are required for this purpose. Now we'll go ahead. Ultrasonic sensor, how it works. Okay, ultrasonic signals, they are of 40 kilohertz. The frequency of ultrasonic signal is 40 kilohertz. Here VCC we are using for giving the power. You have to give the power to this VCC through the Arduino. Here 5 volt is available. Then second pin is the trigger pin. In this trigger pin we are sending the signal for 10 microsecond. Now here we have specified the 10 microsecond value, and we send the 8 cycles through this trigger pin. And because of that, what happens, the signal of 40 kilohertz propagates through the media, and if they whenever they collide with some obstacles, they return from that obstacle, from that we can say that object, they come back, and that is received by the pin number 3, that is echo pin. Okay, and grounding is used for maintaining the reference voltage across the VCC. Okay, now this is the how this ultrasonic sensor work. This is all about. Now how to make the connection, see that. Now first of all you connect the VCC to the pin number 5. Here is the pin number 5. 2 grounds are there, and then you are having the pin number 5. Here you connect the VCC. Then next you have to connect the trigger pin. For the connection of the trigger pin, here you can see the circuit diagram. Here is the circuit diagram. Now trigger pin you have to connect to the pin number 2 of digital pin number 2 of the Arduino board. Here I have connected pin number 2. Then this is the trigger pin. Okay, now this is the trigger pin. Okay, this is the trigger pin. Then next pin is the echo pin. Echo pin you have to connect to pin number 3 of the digital Arduino side. Okay, and last pin is remaining that you need to connect at ground. Okay. Sometimes leads are not straight, it takes time. Okay, 2 grounding pins are there, anywhere you can connect. Now it's time to connect the buzzer. As shown in the circuit diagram, you have to connect the buzzer in between pin number 10 and ground. Red you have to connect to pin number 10, and again grounding is also there on the digital pin side. Okay. Now in this way connections are over. Now why we have connected to the pin number 10? Because we have, through the programming, we are going to initiate the pin number 10 whenever the specified distance is wave travels the specified distance. Similarly we are using the pin number 2 and 3 respectively for trigger and echo. Now here the connections are over. Now it's time to go for the programming. Now how to do the programming? For that purpose, see the logic. Now we know that the distance traveled by the ultrasonic wave is given by V multiplied by T. Here S is the distance covered by the ultrasonic wave, V is the speed of sound wave, T is the time. Now we know that the speed of sound is 340 meter per second. If we convert it in terms of centimeter per microsecond, it comes 0.34 centimeter per microsecond. Therefore the distance covered becomes 0.034 multiplied by T. Now this distance will be in terms of centimeter, okay, because we have done the conversion. But now this distance is to and fro, means from the ultrasonic sensor to the object and from object to the sensor. But now as we have to calculate the distance only from the sensor to the object, we have to divide this total distance by 2. Therefore S become the 0.035 multiplied by T divided by 2. Now this is all about the calculations for the distance covered by the ultrasonic wave. Now we will go for the coding. For that purpose, first of all I will open the Arduino software. Okay, Arduino software as is there on my desktop. Now already here I have written the program. Now here you can see that how the program works. First of all I am initiating the trigger pin number 2. Then echo, second one is the pin number 3 is initiated as a pin number 3. Then for buzzer, pin number 10 is in use, digital pins. Then time is also initiated, then distance is also initiated. Then in the single loop, here we have to set the baud rate 9600. Then trigger pin will be the output pin, where the 40 kilohertz 10 microsecond 8 cycles will be transmitted. Then echo pin will be used as an input pin. Then buzzer pin will be output pin, and that will be initiated depending upon how much distance we require. Then in the second looping programming, you see that digital write trigger pin will be high for 10 microsecond. Okay, here all the values are given in the microsecond. Then after 10 millisecond, the digital write trigger pin will become low. Then distance will be calculated depending upon the input received by the echo pin. Okay, then how much is the distance, how much is the time taken by this wave to travel from the sensor to the object and back to the sensor receiver, means from transmitter to the object and object to the receiver of the ultrasonic sensor. And based on that we can calculate the distance. That formula also we have seen in the last discussion. Now we will set that if the distance is less than 10 centimeter, then you will see on the serial monitor, you will see that door is open and that distance will be displayed. Okay, and a buzzer will become on. This condition will be valid only if the distance is less than or equal to 10 centimeter. Okay, but if the distance is more than 10 centimeter, then on serial monitor you will see the message door closed and distance value will be shown. Now this value 10 microsecond, this 10 centimeter you can change, and accordingly you can make your you can personalize your doorbell. Okay, for how much distance you want to hear the buzzer. Okay, now we will go ahead. Now first of all what you have to do, you have to do the validation. Okay, first of all click on this right verify knob. Okay, then once you did the verification, the next one is upload. As I have already done the verification as well as the uploading, I will not do it again. Okay, but this is very simple and straightforward procedure, you can do it easily. Once that is done, now it's time to check the result. Okay, for that purpose you need to plug in the cable. Now you plug in the cable, then when you will just insert, then power supply will be provided. Now here is the sensor. Okay, now connections are over. Now you can see that how the sensor work. Now if I put if I hold my hand over the ultrasonic sensor, you can see that no voice you can hear. But now as I go close to this ultrasonic sensor, you will hear a sound. Okay, now connections are over, and you can see that how the ultrasonic sensor work. Now if I hold my hand far away from the ultrasonic sensor, you will not hear any kind of sound. If I just go below, and when my hand is close to the ultrasonic sensor, you will hear a sound. You start hearing this sound if my hand distance is equal to or less than 10 centimeter, because that we have set in the programming. This distance also you can change. How the result will look like, that you can see